Today we're going to look at Module 3, Lesson 1, Graphing Relationships. After this lesson, you should be able to describe a relationship given a graph, and then sketch a graph given a description. So if we look at the first example here for interpreting graphs, I do believe this should be page 26 in your notebook. So our question is here, the distance a delivery van is from a warehouse varies throughout the day. The graph shows the distance from the warehouse for a day from 8 a.m. to 5 p.m. So we're talking about the distance, we're talking about a van driving, and we're going from 8 a.m. Oh, goodness gracious. Not working much better, is it? 8 a.m. to 5 p.m. So we're looking at all the time throughout that time. So segment 1 shows that the delivery man moved away from the warehouse. So this here is showing away from the warehouse. If you look, we're going from here up to here. So it wants to know, what does segment 2 show us? Well, segment 2 is going to be from here to here. So what would segment 2 be showing us? If we look at that, our distance is increasing. It's going from here up to about here in distance. So our distance is increasing, and so is our time. So what we're going to say is that segment 2 is going to show the van moving away. But if you look at it, it is taking a longer time to get from here to here than it did to get from here to here. So we're going to say the van is moving away slower than segment 1. So if we look, segment 1 went really quickly high. It went from it wasn't moving at all till really far away in a short amount of time. And then from 1 to 2, it was maybe around the same amount of time, maybe a little bit longer, but it didn't go nearly as far. So it had to have been moving slower. So based on the time frame, what change in the distance from the warehouse is represented by segment 6? So if we look, segment 6 is this one right here. So it wants to know what's the difference there. So if we're looking there, we're going from this part here, like this distance here, down to this distance. So that's actually showing us that it's getting closer to the warehouse. So if we look at letter C, which line segment shows intervals where the distance did not change? So if we go back up here, where do they not change it? Where does the distance not change at all? And if we look, there's a couple of them actually. So there is this part right here, this part right here, and this part right here. So where they don't change would be intervals 3, 5, and 7. And then it says, well, what's a possible explanation for these segments? Well, a possible explanation, I don't know, if we're talking about a delivery truck, that might be where it's making deliveries. And why would I be saying that? Because where the distance isn't changing, that means the truck is stopped. And it looks like it stopped for more than like a minute. It looks like it stopped for a decent amount of time because remember, this is going from 8 a.m. to 5 p.m. So that stopped for a decent amount of time, so that's probably a delivery that it's making. Okay, so that's a quick overview here of how we could interpret a graph. Now let's look at relating information to graphs. So our example here is that there are 3 hoses that fill different water barrels. A green hose fills a water barrel at a constant rate. Black hose is slowly opened, and then the blue hose is completely open at the beginning and then slowly closed. The 3 graphs are shown, but we're going to have to go ahead and figure out which one's which. So the first question says, which is best represented by the amount of water in the barrel filled by the green hose? Well, if we go back up here, the green, that's not what I want. The green hose fills at a constant rate. So something that's constant, that would look like this here. This is a constant rate of change, okay? When we're looking at the rate at which the water is flowing, it's a consistent rate. It doesn't really change. It's always going at the same amount of gallons per hour. So which graph best represents that? That would be graph B. If we want to describe the water level represented by each graph and determine which graph represents each scenario, so graph A, if we look at that, we're starting off where our water, remember this is our water in gallons, it's really, really low, and then all of a sudden, choop, it gets really high. So what we would probably want to say is something like, oh, right, this is not the kind of pen I want. There we go. Something like the level is low and increases over time. For letter C here, notice that it shot up really fast and then it got slower and slower to rise. So for letter C, it increased rapidly in the beginning. And then slowed down. Okay, so if we look at this here, it said a black hose is slowly opened when filling the barrel. So out of these 2 graphs, the black hose would have to be the one that shows the water filling really slowly at first. And that would be letter A. So graph A is the black hose, and graph C would be the blue hose. It's completely open in the beginning, and then it changes. It gets smaller over time. Okay, so I want you to go ahead and try this. What you want to do is you want to read over it. You want to pause the video, read over it, and then you will get to see the answer once you click again. So it said a friend are playing catch, you throw the ball, throw the second ball in an arc, and this time it gets stuck in a tree, and then you throw the ball directly at your friend, but it lands in front of your friend. So if you're looking at this, which graph represents the situation where the ball gets stuck in the tree? When the ball gets stuck in the tree, that would be graph C. It goes up high, and then it never comes back down. The height of the ball represented by the other 2 graphs, well, in graph A, the height of the ball is kind of consistent with your height. You're throwing it and doesn't really get much higher, and then remember it's going to the ground in front of your friend. So it goes to the ground in front of your friend, and all of a sudden there's no height there. The other one goes up in an arc and comes back down. So it's going up high and then back down, and your friend catches it. So that's a nice arc shape there. Okay, so sketching graphs for different situations. If we're looking at this here, we want to look at continuous graphs, discrete graphs, information like that. So we need some information first, some definitions. So a continuous graph is one that has connected lines. So it's going to have connected lines throughout. It's not just a bunch of dots. A discrete graph is going to be one that has distinct unconnected points. So it's just going to be a bunch of dots on a graph. They're not going to be no connection at all in any way. So when we're looking at this, something else we're going to be asked to find is domain and range. And I know you guys have heard of those before, but we're going to go over that again here really quick. Domain would be, in terms of a graph, it's all of the x values your graph contains. And the range would be all of the y values. So domain and range, all of the x values your graph contains, or all of the y values your graph contains. So if we look here, let's look at our first one. Sketch a graph of the situation, tell whether the graph is continuous or discrete, and determine the domain and range. So this one here, a student is taking a test. There's 10 problems. For each problem the student answers correctly, the student receives 10 points. So if you look at your graph here, if they answer 0 problems, they get 0 points. If they answer 4 problems, they would get 40 points. 6 problems, they'd get 60. So this is the amount they would answer if they're correct. Notice on this graph, there's no line in between. That's because if, for example, you had a line here, that would mean that you could have a question between like 3 and 4, for example. So you could have between 3 and 4 problems correct. That's not true unless you grade like some teachers, like I do, and you get partial credit. But you can't just have a problem like partially correct in terms of this case. So this is what we would call a discrete graph. And then the domain would be what values what x values are included. So the domain would be from 0 to 10. And the range, that's your y values. So that means what points can you get? You can get from 0 to 100 points. The next one here is a bathtub being filled with water. After 10 minutes, there's 75 quarts in the tub. So after 10 minutes, there's 75 quarts in the tub. That'll be somewhere around here. Someone accidentally pulls the plug, and the tub loses 15 quarts in 5 minutes. Then someone plugs the drain, and it keeps going from there. So what happens is you actually end up getting something along this line, because remember, at a certain amount of time, it's going to be at a certain level. It may not be when you actually measure it, but it will be at a certain level at that point. So this graph is a continuous graph. It goes from 0 to 46 minutes based on this here, and then from 0 to 100 minutes. It says here, by the way, it takes 11 minutes for the tub to drain. That's how we got the 46. So 0 to 46, 0 to 100 being how many quarts are in there. Or is it? Yes, 0 to 100.